Alright, Algebra 1 people, this is your Chapter 3 study guide. Start with number 1. Alright, so for all of these, you were supposed to answer one, if not two questions. The first question was, is it a function? And then if it's a function, then you had to tell me if it's linear. So we're going to start right here. For this one, you should have said not a function. Going all the way back to your 3.1 stuff, you've got one input here going to two different outputs. So as our vending machine analogy, that's like one button that gives me two different things on a vending machine, not functional. For number 2, over here, you should have looked at that and said, yes, that's a function. This is straight up y equals mx plus b. That should look totally normal. So you should be able to say, yes, it's a function. And then, since it's y equals mx plus b, you should also say, yes, it's linear. So yes and yes. All right, for number 3, so I don't have any repeating x values. We're going back to a table this time. I don't have any repeating x values, so you should say, yes, it's a function. And then to see whether or not it's linear. So we did this in class a few times. You look at the change in x's versus the change in y's. Now the change in x's, it looks like it is going up 1 every single time. To get from -2 to -1, you go up 1. -1, 0, up 1, up 1. On this side, it looks like it's going up 2 every single time. So since that is a constant rate of change, you would say, yes, it's linear. Alright, this last one's a little trickier. Y equals 3x squared minus 4. Do you know if that is a function or not? The only reason you would have been able to tell that yes, this is a function is because you could have written it as f of x equals 3x squared minus 4. So that goes back to our function notation days, f of x. So you should have said yes, it's a function. But you also should have looked at this square and said, no, it's not linear. That's it. Cool. All right, let's move down to number 5. So we had a couple of questions here. Discrete or continuous, then domain and range. So for this one, you should have said this is continuous because it's a connected line. It's not a bunch of dots versus number 6, which is discrete. We'll get there in a second. So back to number 5. Let's do my domain. Now, you don't have to write your domain exactly like this, but I'm going to use brackets, and then you just don't need this part. You do need the compound and statement with an x in the middle for domain. All right, so I'm going to look at my smallest x value. If I go all the way to the left, it looks like my smallest x value is here at -3, which is less than or equal to, because that's a closed circle, my largest x value. So as far as I can go to the right, which looks like here, and that is at 5. So less than 5. No or equal to line, because that's an open circle. Okay, so there's my domain. Now for range, I'm still going to use brackets. It's going to have a y in the middle, and I'm going to start with my lowest y value. We're doing up and down now. My lowest y value looks like is here, but we're looking y values, so that's 0 less than or equal to y. And then my highest y value is here, which is at 11, so less than 11. Kind of tricky there. Now compare that to number 6. This is a discrete graph, meaning it's a bunch of dots. Okay. So now if I'm going to write my domain, it's actually just going to be a list of numbers, and it's going to be all my x values. Now there's 6 points here. You could go through all 6 points and write out the coordinates and then write out the x values, or you could just kind of look at what, like these two line up with -3, these two line up with -1, these two line up with 2, or excuse me, +1 and +2. So you can see where your points line up on the x-axis. Now don't repeat inputs. So my domain here is -3, 1, 2. because those are the 3 different places where I have points line up on the x-axis. Now for my range, I'd do the exact same thing, but I'd see where do they line up on the y-axis. And here, looks like I've got a few more y values. So these line up -4 on the y-axis. This point is at -2 on the y-axis. And we have +2, +3, +4. So 2, 3, 4. Notice I wrote them in order from least to greatest. That's it. I didn't even ask you whether or not this is a function, but you should be able to tell me yes. All right, come right here. So I give you 3 different numbers to plug in, so you should have 3 different answers. So first one, f of 0, just means I'm plugging in 0. 0 plus 7 equals 7. Hey, look at that. That's pretty neat. F of 5. 5 plus 7 equals 12. So 2 of my 3 answers right there. And then lastly, f of 10, which is 10 plus 7, and you should have gotten 17. So my 3 answers here should have been 7, 12, and 17. Now number 8 was a little bit more fun. So I'm plugging in those same 3 numbers, so g of 0, but I have 2 different places where I'm going to plug in a 0 this time. So 0 plus 3 minus 5 times 0, well, -5 times 0 is 0, so all of this comes out to 3. I'll do the same thing by plugging in 5. So 5 plus 3 minus 5 times 5. Notice I plugged in x in those 2 different spots. Excuse me, I plugged in 5 in those 2 different spots where you saw an x. So 5 plus 3 minus 25, that all comes out to a -17 is my second answer. 5 plus 3 is 8. 8 minus 25 is a -17. And the very last one was plugging in 10. Again, I'm going to plug in 10 into the 2 different spots where you saw an x. So I've got 10 plus 3 minus 50. And that comes out to a -37. So my 3 answers here should have been 3, -17. All right, now we're on the back and we're looking for the slope. So this that I've circled right here is a point. So -3 comma 6. -1, 2, 3, comma 6. So if you wanted to, you could graph it. Then you could graph this next point, 0, comma 4. Sorry about these. And I could look at the slope in between those 2 points if I wanted to. Here's another way to do it without graph paper, because I'm assuming a lot of you don't have graph paper at home. Slope is rise over run. Now, the rise is just how my y values change, like how far up or down do I go, and the run is how my x values change. So, well, let's look. If I'm looking at my y values, as I go from one point to the next, it looks like I'm going down 2. 6 minus 2 is 4, 4 minus 2 is 2, 2 minus 2 is 0. So my change in y is -2. Now let's look at my change in x. As I'm going from point to point, it looks like I'm going up 3. Sorry if you can't see that very well, but I'm going up 3, +3. Therefore, my slope is -2/3. And you can see the same thing in the 2 points that I graphed. If I go from my left point to my right point, I go down 2, and then I go right 3. Same thing over here. I'm not even going to use the graph. I'm just going to look at my rise over my run, my change in y's and my change in x's. Now, y doesn't change at all, so that actually has a change of 0, whereas for my x values, it looks like it's going up 2. Doesn't matter a ton, but my slope here would be 0. All right, we're on number 12. This is slope-intercept form. You had a graph. Don't forget y equals mx plus b, where m is the slope or rise over run like we were just talking about, and b is the y-intercept, aka my starting point. So I'm going to start with my y-intercept, and I'm going to place a dot -3 on the y-axis. Then I follow my slope. Now my slope should be a fraction, and if it's not a fraction, we can always make it a fraction by putting it over 1. 2 over 1. So up 2, write 1. Up 2, write 1. Up 2, write 1. You didn't actually need all 4 of those points. You really just needed 2. But I like to make as many as possible. And I've heard at least one of the middle school teachers told you to do the same thing. Can't hurt, right? All right, then when we look at number 13, this is no longer in slope-intercept form. This is in standard form, so we got to do some math first. We got to put this into slope-intercept form. So we are going to start by getting rid of my x's. Now this is the exact same thing you needed to do in your Khan Academy practice the other day. This will go away, and I'm left with 2y equals negative 3x plus 6. Don't forget, not like terms, so you cannot squish these two things together. Okay. And lastly, I'm going to divide everything by 2. I get y equals negative 3 over 2. There's nothing I can do to simplify that, so I'm going to leave it as negative 3 over 2. 6 divided by 2 is 3. Now, I have not changed the line itself. These two equations are the same. Just one's written in standard form, one's written in slope-intercept form. So if I were to graph both of them, it's the exact same line. All right, so here, again, we're going to start at my y-intercept, which in this case is positive 3, so I put it out at positive 3. And my slope says negative 3 over 2, meaning I'm going to go down 3, right 2. I can even put another point if I wanted to. And there's my line. Don't forget to connect them. Put arrows at the end. All right, last 3, 14, 15, 16. These are all asking for slope and y-intercept. Well, 14, this is in y equals mx plus b form, aka your slope-intercept form. So everything's just written right there for you. My slope in this case is the thing right in front of x, so negative 1/4. Easy enough. Now my y-intercept is the thing at the end, but be very careful here. I'm not just going to write b equals negative 6, because your y-intercept is a point, where negative 6 is your y value, and your x value in this case is 0, because we're touching the y-axis. Everywhere on the y-axis has an x value of 0, because it hasn't gone to the left or the right. Now 15 is a little bit more fun. 2x plus 5y equals 15. I cannot tell what the y-intercept and slope are based on how it looks, because standard form sucks. So I'm going to do a little math first, and I'm going to change this into slope-intercept form, just like I did in number 13. We are going to subtract 2x. I will get 5y equals negative 2x plus 15. And then lastly, I'm going to divide by 5, and I get y equals, let's see, negative 2 over 5. There's nothing I can do with that. So negative 2/5 x plus 15 divided by 5 is 3. Now, if I'm staring at this, now it becomes a lot more apparent what my slope is and what my y-intercept is. I can come back here and I can write those. My slope, in this case, was negative 2/5. And my y-intercept, which we are going to write as a point, the y-intercept always has an x value of 0 and it has a y value of 3. All right, last one on here. Now this one might have been kind of tricky for you if you don't know what the graph of this equation looks like. If I were to draw a little graph here, if you remember from our notes, we said anytime it says y equals a number, it is actually just a horizontal line. It's a flat line. Now this is a flat line at y equals negative 2, meaning this value right here is negative 2. So you should be able to tell me the y-intercept is 0, negative 2. The slope, depending on how well you paid attention in class, might be trickier, but a flat line always has a slope of 0. In class, we did talk about how you could rewrite this as y equals 0x minus 2 if you want, and then it becomes a little bit more apparent that it has a slope of 0. But that's it.